ఇంకో చైర్ తెచ్చుకుందామా? తెచ్చుకుందాం. ఒక చైర్ తెస్తారా? ఇక్కడ వేసి సారీ పెడదాము. చెప్తున్నా ఇది అవుట్ ఆఫ్ థ్యాంక్స్ సంజయ్ ఒక చైర్ తేవా సారీ ఇక్కడ పెడదాం. ఎన్ని చైర్లు క్లాస్ అయితే మళ్ళీ రాక మనం శ్రీకాంత్ సార్ బయట కూర్చుంటారు.
వైర్ తాకితే లైవ్ స్ట్రీమ్ పోతుంది. మళ్ళీ వైర్ తాకండి.
ఇక్కడ రాదు కదా మనం ఇంకో చైర్ తీసుకుంటారు కదా. జరపాలి మేడం సార్ వాళ్ళు పిక్చర్ ఐడియా నాలుగు మేడం గుర్తు చేయదు మేడం. నిద్రలో వేసుకోవాలి బయటలో పడేస్తారు. బస్ ఎక్కగానే మళ్ళీ తీసుకుంటారు. ప్లీజ్ ఫిల్ ద ఫీడ్బ్యాక్ ఫామ్ కూడా చెప్పాలా? చెప్పాలి కదా.
అంతే అజెండా ఎట్లుంటుంది. ఆయన ఒకసారి మేడం రిసోర్స్ పర్సన్ గురించి చెప్పినాక విత్ దిస్ బ్రీఫ్ ఇంట్రడక్షన్ టూ రిసోర్స్ పర్సన్ డాక్టర్ పురుషోత్తం యాదవ్ అని చెప్పేస్తారు. అంతే మేడం ఇంట్రొడక్షన్ ఇచ్చి ఆయన హ్యాండ్ ఓవర్ చేసేస్తారు. హ్యాండ్ ఓవర్ ద సెషన్ టు పురుషోత్తం సార్ అని చెప్పేస్తారు. వెల్కమ్ సార్ అని చెప్పేసి క్లోజ్ చేస్తారు. ఇక సారు స్టార్ట్ చేసుకుంటారు. అంత అయిపోయినాక మీరు అందుకుంటారు. వండర్ఫుల్, ఇట్ వాజ్ ఏ వండర్ఫుల్ సెషన్ సార్. నౌ ద టైం ఫర్ క్వెరీస్. క్వెరీస్ అడుగుతారు. దాని తర్వాత క్వెరీస్ అంతా అయిపోయిన తర్వాత ఓట్ ఆఫ్ థ్యాంక్స్ గురించి ఎవరు ఉన్నారో ఆ మేడం మీరు చెప్తారు. మేడం ఓట్ ఆఫ్ థ్యాంక్స్ చెప్పేస్తారు. అయిన తర్వాత మీరు ఒకసారి ఫైనల్ అనౌన్స్ చేస్తారు. ఓకేనా? ఫీడ్బ్యాక్ is kept in the chat box. Please fill the feedback to get the e-certificate. E-certificates will be issued within a 1 week. చెప్పండి 1 week అని చెప్పండి కానీ మనం సాయంత్రం ఇచ్చేస్తాం. ఏ లింకు?
ఆ గ్రూప్ లో ఉన్న లింకే మళ్ళీ ఈ రోజుకి అంటే చాలా మంది అంటే లింక్ పెట్టిన తర్వాత చాలా మంది జాయిన్ అయ్యారు.
మధ్య మధ్యలోకి ఇది అనౌన్స్ చేయండి. ఒకవేళ 100 దాటింది అనుకో, మీకు అక్కడ నెంబర్ ఆఫ్ పార్టిసిపెంట్ 100 నిండిపోయింది అనుకోండి, those who are not enabled to join through Gmeet, we are providing the YouTube link also.
సెషన్ స్టార్ట్ చేసిన తర్వాత చేయకూడదు.
స్టార్ట్ చేయకన్నా ముందే 10:30 లోపే, ఎందుకంటే ఇప్పుడు ఆల్రెడీ జాయిన్ అవుతుంది చాలా మంది.
సార్ వచ్చేసరికి ఇద్దరు ఉన్నారు, నేను వచ్చేసరికి ఇద్దరు ముగ్గురు. 11 మంది అయ్యారు. మనం జాయిన్ అయితే నువ్వు జాయిన్ వాళ్ళు దాచిపోతారు.
మేడం ఒకసారి నేను యూట్యూబ్ లింక్ పెడతాను, ఓకే? నాకు గట్టు బయటికి పోయి ఆ లింక్ ఓపెన్ చేస్తే లైవ్ సెషన్ ఓపెన్ అవుతుందా లేదా చెక్ చేసి చెప్పండి. ఫోన్కి ఎవరి ఫోన్ పెట్టాలి చెప్పండి. ఫోన్ పెట్టదా? చూడండి మేడం
So, we have an hackathon Saturday. So, we are inviting to the seminar hall for the admission ceremony. As Ashwadi ma'am is not present in her cabin.
But better to invite Ashwadi madam only. She will be there after. She will come now. She will come. Let her come now, better. Within 5 or 10 minutes she will come. Okay, no?
ఇదే కదా షేర్
ఏం కనిపిస్తుంది?
ఇదే కనిపిస్తుంది, ఈ స్క్రీన్ కనిపిస్తుంది.
అట్లే ఉంచండి. గూగుల్ మీట్ ఓపెన్ చేస్తే అది కనిపిస్తుంది చెప్పండి. కొద్దిగా 3 seconds గ్యాప్ ఉంటుంది. అందుకే నా భయం. మ్యూట్ కూడా తినిపిస్తుందా చూడండి ఒకసారి. అటుకోండి, నేను ఇప్పుడు మాట్లాడేది అంత వినిపిస్తుందా మేడం? ఇప్పుడు నేను మాట్లాడేది వినిపిస్తుందా? వినిపిస్తుందా? సో మ్యూట్ కొట్టినా వేస్టే, మనం జాగ్రత్త మాట్లాడు మేడం. ఇవి బహిరంగంగా అందరికి వినిపిస్తున్నాయి, జాగ్రత్త, మెల్లగా మాట్లాడుకోండి. యూట్యూబ్ లింక్ పెడుతున్నా కాసేపట్లో, మనం చిన్న మాట్లాడినా అందరికి వినిపిస్తుంది. అదే మేడం అబ్జర్వ్ చేసి తీసేయండి. పని చేస్తుందా లేదా అందుకే చెక్ చేయమని, అంతే. నాకు తెలిసి 100 కన్నా ఎక్కువ జాయిన్ గారు, 300 రిజిస్ట్రేషన్లు అయినాయి, కానీ మన ధర్మం పెడదాం యూట్యూబ్లో. కనెక్షన్ పోయిందా? అందుకే సిస్టమ్ చేయడు.
నాకు అవసరం లేదు, నాకు అవసరం లేదు, మీరు హ్యాండ్ ఓవర్ చేస్తారు. మిమ్మల్ని చేయమన్నారు. The session hand over to Dr. Kaushik Kunji and I'd like to hand over the session to our research person.
అంతా చదవడైపోయినాక introduction, I would like to hand over this session to our resource person, Dr. Bas, అయిపోతుంది.
Thank you, sir.
ఇంట్రొడక్షన్ వినిపిస్తుందా అందరికి? మనం మాట్లాడేది యూట్యూబ్ ఇంకా నేను ఎవరికి షేర్ చేయాలి, అందుకే అందరికి లింక్ పెట్టలే గ్రూప్ లో. సార్
అంతే సార్, మళ్ళీ డాక్టర్ ఇదంతా ఎందుకు సార్? మళ్ళీ
అవసరం లేదు.
like to hand over the session to our resources. Sir, please help. అంతే కదా సార్? Our resource person. Sir, please welcome. సార్, నేను ప్రౌడ్ జ్వల్ దగ్గర జమ్ అన్నాను అనుకుంటున్నాను. ఎందుకంటే జ్వల్ అనే పదం రకరకాల బాగా వినిపిస్తుంది. సార్ ప్లీజ్ అంతే సార్
యూట్యూబ్ లైవ్ స్ట్రీమ్
ఇది వద్దన్నారు కానీ చెప్పొద్దన్నారు మీరు చెప్పేస్తారు మేడం మీరు మేడం అడిగారా नहीं डिसाइड
अभी कर सकते हैं हमको इधर टाइम लगेगा
సార్ మన బేసి సార్ ఎవరెవరు చదవాలో మీరే చెప్పారా మేడం మనకి
దాని కూడా మనం మేడం అడిగితే మరి పరమానంద శిష్యులు అయిపోయింది
చూసారా వాళ్ళు కింద స్క్రోల్ అవుతుంది యూట్యూబ్ లో సార్ అదే మనం కూడా చేద్దాం సార్ చేసేది అసలు సార్ అసలు ఏదన్నా చేస్తే మాత్రం మా స్క్రోల్ చూపిస్తాడు సార్ వెరైటీగా చేస్తున్నారు మేడం ఈసారి మీట్ చేయాలని చూస్తున్నారు మొబైల్ నెంబర్ రిజిస్ట్రేషన్ నెంబర్
At least in that one also physics is
one position at least one number and
330.
254
yes thank you sir at least in one condition we are in high
మన ఎంతనే గ్రూప్ లో చూడండి
330 morning 320 that నేను బస్ ఎక్కిన తాత వచ్చి ఈసీ వాళ్ళందరికీ ఎలక్ట్రానిక్స్ జాయిన్ అవ్వండి
330 sir అయ్యారా మంచి పని మీరు ఎగ్జామ్ పడుతున్నారు జాయిన్ మస్తు
కింద కూర్చోవాలి అన్నమాట ఒకటి తీసుకొని రావాలి కింద కూర్చోవాలి మళ్ళీ వెళ్ళాలి మనకి 3 సార్లు రావాలి ఫస్ట్ వెళ్ళాలి అక్కడ గేట్ దగ్గర అది నేను నిలబడలేదు మధ్యాహ్నం నేను అప్పటిదాకా ఎగ్జామ్ ఆయన అడిగాడు ఒకసారి మరి ఎగ్జామ్ మ్యాచ్ లో 10 దాకా ఉన్న మీ సార్ పక్కన నిలబెట్టింది వాళ్ళు నిలబడమని చెప్పి నిలబడేదాన్ని నా నిలబడేదాన్ని వస్తారు మళ్ళీ 10:30కి రావాలి గేట్ దగ్గర 10 నిమిషాలు 9 తర్వాత 10:30కి వెళ్ళాలి పైకి వెళ్ళాలి అన్ని వాళ్ళకి వెళ్ళి పౌన్ తెచ్చుకొని అతన్ని పట్టుకురావాలి ఇది ఇచ్చినాక మళ్ళీ అక్కడ కూర్చోవాలి సో మొత్తం వచ్చే 12 ఇన్వెస్ట్ చేయడం
ఒక వాటర్ బాటిల్
అడుగుతారు ఆఫీసర్ని 10 దాకా రావడానికి ఫోన్ చేయలేదు నేను అక్కడ ఉంటే గేట్ దగ్గర నిలబడలేదు ఆయన పక్కనే ఉన్నాను మేడం నేను 10 ఫోన్ చేయడానికి అన్నాడంట 2 to 10 minutes వరకు నేను చాలా ఎగ్జామ్ రాసుకునే ఉన్నాను
ఎంతమంది లీవర్స్
ఎవరు
ముగ్గురు కాబట్టి అసలు మీరు అన్నట్టు 10-15 నిమిషాలు
అది కాదు నేను అప్పుడు ఎగ్జామ్ రాసుకునే ఉన్నాను ఎవరంటే నిలబడతాను ఆడవుతాను
నేను ఇంకెంతమంది పేరెంట్స్ వాళ్ళకి ఏం పర్లేదు
నాకు 4 సార్లు నా పైన చచ్చిపోతాను
నా కాలు మళ్ళా స్టార్ట్
సాయంత్రమా ఉదయం
6:30 to 8 మళ్ళీ రేపు పొద్దున ఇట్లా రేపు నైట్ మా పాప స్కూల్ డాన్స్ 11:30కి డాన్స్ నువ్వు రావాకు అని చెప్పింది సేపు ఉండలేదు మా అబ్బాయి పోతాడట హాలిడే ఇచ్చారు ఆర్డినరీ ట్యూస్డే కూడా హాలిడే అప్పుడే
పోలీస్ పెట్రోల్
మండే కూడా ఇస్తారు హాలిడే ఇవాళ
మేడం అంటే ఓవర్ మేడం
మా అబ్బాయి పోయినసారి 12కి వచ్చిండు వాడు కమిటీలో ఉండు 12:30కి ఏమో ఇంటికి వచ్చిండు ర్యాపిడో బుక్ చేసుకొని
జాగ్రత్తగా వాళ్ళ టైంలో అసలు పంపించారు ర్యాపిడో బుక్
అసలు వాళ్ళేం మా అబ్బాయిని పంపించారు మేడం మర్చిపోయి బస్సు వాడు ఆ కమిటీలో ఉండు మేనేజ్మెంట్ దానికోసమే
ఇప్పుడు నాకు టైంలో నాగమైన రాసి పదింతకులు మెసేజ్ పెట్టి ఇప్పుడు చెప్పాను మధ్యాహ్నం పంపిస్తాను చాలా వచ్చింది పెట్టాలంటే నవ్వుతున్నాను పెట్టాలంటే చాలా వచ్చినాయి మీరు పెట్టండి కావాల్సి అదే సార్ మొత్తం సార్ పంపించారు
కరెక్ట్ వైండ్ అప్ చేస్తారు 12:30కి అంటే వాళ్ళు కాబట్టి పంక్చువాలిటీ ఉంటుంది ఎవరు నో థ్యాంక్స్ అన్న దీంతో పెద్ద పదార్థం
అది బాగా అవుతుంది సాయంత్రం జైన్ సంబంధం ఎందుకంటే ఉంటే జాయిన్ అయితే బెటర్ జాయిన్ అయ్యి మ్యూట్లో పెట్టుకొని ఉంటే ఎందుకంటే సడన్ గా అందరూ ఒకసారి జాయిన్ అయ్యారు అనుకో సార్ జాయిన్ అవ్వడం కూడా జాబ్ ఉన్నది ఒకటేసారి టైం అయిందని అందరు జాయిన్ అయినప్పుడు అప్పుడు సార్ జాయిన్ అయినామంటే ఇట్లా
మీరు జాయిన్ అయ్యి వాడు పోలీసు మా సార్కి ఎలా జాయిన్ అవ్వాలి కూడా రాలేదు 5 నిమిషాలు అదే పెట్టింది
Sir, madam, leave a person.
No, sir.
Leave.
No, maybe better. Sometimes madam will come after me. Sir, sir,
అమ్మో ఎంతమంది జాయిన్ అవుతుంది ఒక్కసారి తెలుసు తెలుసు నన్ను మెసేజ్ పెట్టిండు అప్పుడు బాగా పట్టించు
మొత్తం ఉంది సార్ బాగా
ఎంతమంది 30 మంది అంత కొడితే 30 మంది అయినా అంతే
2 నిమిషాల్లోనే 15 మంది
Good morning. Morning to all. Morning to all. The session is about to start. Please join immediately. వచ్చిందా నీళ్ళ సప్పుడు?
వచ్చింది.
ఇది ఆడియో.
చాలా మంది మీరు లింక్ పెట్టిన తర్వాత జాయిన్ అయ్యారు.
పెడతా
18 మెంబర్స్ మీరు లింక్ పెట్టిన తర్వాత జాయిన్ అయ్యారు వాట్సాప్.
ఓకే చేస్తాను.
యూట్యూబ్ లింక్ మీ దాంట్లో షేర్ చేస్తుందా మీ ఛానల్?
ఏం లేదు సార్.
మ్యూట్ పెట్టేస్తాను కదా,
ఆన్లో పెట్టుకోవాలి.
ఒక్కటే పెట్టాలి. ఏదైతే మాట్లాడుతుందో అది ఒక్కటే పెట్టాలి.
ఓన్లీ స్పీకర్స్ ఆఫ్ చేసుకోవాలి. హాయ్ సార్, జస్ట్ రిసీవ్ ద లింక్ అట. రిసీవ్ ద లింక్ అయితే అటెండ్ చెప్తాను. మళ్ళీ పెట్టలే, పెడదామంటే
48 49
నాగవేణి. ఏం పెడదాం, 10 నిమిషాల ముందు పెడదాం.
గ్రూప్ లో పోస్ట్ చేసినా చాట్ బాక్స్ లో చేస్తారా, గ్రూప్ లో చేస్తారా?
చాట్ బాక్స్ లో చేద్దాం ఫస్ట్.
చాట్ బాక్స్ బెటర్.
సో ఫీడ్బ్యాక్ లింక్ ఈస్ పోస్టెడ్ ఇన్ ద చాట్ బాక్స్ అని అనౌన్స్ చేస్తాం మనం.
చాలా మంది అడుగుతారు.
57.
హెచ్ఓడి నన్ను అడిగినప్పుడు నాకు తెలియదు.
అయితే మనకి రాలేదు, అంత రాలేదు.
అంటే మేడం కూడా పట్టించుకోలేదు, అడగలేదు. నేను శాంతిలత మేడం అడిగాను. అంటే దాంట్లో జాయిన్ సిస్టంలో జాయిన్ ఇప్పుడు నేను జాయిన్ అయ్యాను. దాని తర్వాత ఎగ్జిట్ అయిపోతే నాకు సర్టిఫికేట్ ఇస్తారా? ఇక్కడ చూస్తాం ఎంతసేపు
ఎట్లా చేయాలి?
సార్ ఒక 100 ఉన్నాయి సార్. 100 మెంబర్స్ అయ్యారు అనుకుంటారు సార్. 100
మాకు సంబంధాలు పెడితే సర్టిఫికేట్ ఇవ్వాలి సార్. సెకండ్ సార్ వింటాం. ఫీడ్బ్యాక్ ఫీడ్బ్యాక్ వచ్చినప్పుడు వచ్చేస్తాం.
పెట్టండి, జాయిన్ అవ్వండి. స్టార్టింగ్ జరిగే కాలేజ్ నుంచి మళ్ళీ మారింది. వెళ్ళిన తర్వాత ఆ ల్యాప్టాప్ ఇట్లా జరుపుకుంటా తర్వాత ల్యాప్టాప్ జరుపుకుంటాను. మా ఆయన ల్యాప్టాప్ బాగా వాడాలి మేడం, దాన్ని బాగా వాడి కొట్టేది. ఛార్జింగ్ ఆగట్లేదు మేడం. ఇదైతే వెయిట్ చేసుకున్నాను. చచ్చిపోయాం మేడం. 5 సంవత్సరాలు
మళ్ళీ మార్చి కొనుక్కోండి.
సెకండ్ హ్యాండ్ ఇచ్చేసి ఇట్లా
లైట్ వెయిట్
సెకండ్ హ్యాండ్ ఇస్తే
ఇలా కనీసం వీడియో ఆఫ్ చేసుకోవాలి
మేడం. అలాంటి
నెహ్రూ కూడా
డిస్కస్ చేయకండి.
ఒక్కసారి మాట్లాడుతూ చాలు సరితో నువ్వు ఒక్కసారి మాట్లాడు చాలు ఇవన్నీ మర్చిపోతావు. శ్రీకాంత్ సార్ డోర్
92 మేడం, నేనైతే యూట్యూబ్ లింక్ పెట్టేస్తున్నాను. అనౌన్స్ అండి ద ప్రోగ్రామ్ ఇస్ అబౌట్ టు స్టార్ట్. Those who are not able to announce and they are posting the YouTube link. ఇప్పుడే 92 వచ్చేసింది అంటున్నా. Good morning to all. The program is about to start. Those who are unable to start through Zoom meet, we are providing the YouTube live stream. యూట్యూబ్ సెషన్ పెట్టినా చిన్నగా మాట్లాడండి, అందరికి వినబడుతుంది. యూట్యూబ్లో వినే వాళ్ళకి వినబడుతుంది మనం మాట్లాడేది. 97 పెట్టాను.
Good morning to all. Dear participants, those who can't join the Google Meet, they can join through YouTube link. YouTube link is provided in the group. Thank you.
అది ఉంచుకోండి. సౌండ్ కంప్లీట్ అది బంద్ చేస్తే రీసౌండ్ రాదు. మళ్ళీ ఒకసారి సేమ్ అదే అనౌన్స్ చేయండి. ఇప్పుడు ఏం రీసౌండ్ రాదు. మళ్ళీ ఒకసారి అనౌన్స్ 100 అయిపోయింది.
Good morning, everybody. Since the participants has exceeded 100, you can join through YouTube link, which is provided in the group already. Thank you.
ఏంటి చాట్ బాక్స్ చూసుకోండి. అవసరం లేదు. వాళ్ళు లోపలికి ఎంటర్ కాదు. ఇక చాట్ బాక్స్ ఎట్లా చూస్తారు? రైట్ 100 అయిపోయింది కంప్లీట్. యూట్యూబ్ లింక్ చూసుకుంటుంది ఎవరు. స్టార్ట్ చేయండి. రైట్.
A very good morning to everyone. Respected principal sir, distinguished guests, my esteemed colleagues and dear participants. It's with immense pleasure that I extend a warm and heartfelt welcome to all of you to this faculty development program on current trends in electronic materials. My name is G. Nagamani, Assistant Professor in the Department of Physics at Malla Reddy College of Engineering, and I am truly honored to host this significant event. Our institution, Malla Reddy College of Engineering, is a gem in the crown of Malla Reddy Group of Institutions MRGI. Established in 2005 with the approval of AICT, permanently affiliated to JNTUH and accredited by NAC and NBA. The college stands as a testament to academic excellence. MRC is situated in Maisamaguda, Dulapalli, Secunderabad. Our college offers BTech courses in cutting-edge fields such as CSE, CSE Data Science, CSE AML, and ECE. The success of this esteemed institution is built on the foundation of strong leadership, experienced faculty, dedicated non-teaching staff, and of course, our talented students. Before we dive into today's program, I'd like to take this opportunity to express my heartfelt gratitude to our respected principal sir, Dr. M. Ashok, whose unwavering support and encouragement inspire us to reach new heights in all our academic endeavors. I also extend my sincere thanks to our Honorable HOD Ma'am, Dr. Sneha Joshi, for her steadfast commitment to fostering a culture of continuous learning and professional growth. Today, we are privileged to have among us our distinguished guest, Dr. Purushottam Yadavji Garu, whose presence adds immense value to this occasion. Sir, we are eagerly looking forward to your enlightenment presentation, and we are sure it will greatly enrich our knowledge and understanding in this domain. This FTP is a wonderful opportunity for all of us to explore the latest advancement, exchange ideas and experiences in the field of electronic materials. Before we proceed further, it's my pleasure to invite my esteemed colleague, Dr. Y. Sarita Kumari ma'am, to give a brief introduction about our distinguished guests, Dr. Purushottam Yadavji. Once again, a heartfelt welcome to everyone. Let's make this program a grand success together. Thank you so much.
Good morning to one and all. This is Dr. Y. Sarita Kumari, Assistant Professor in Physics, Department of Humanities and Sciences, Malla Reddy College of Engineering, Hyderabad. A warm welcome to you, sir, and participants. Today, resource person Dr. Purushottam Yadavji, currently working as Scientist at Center for Materials for Electronics Technology, CMAT, Hyderabad. which is a Ministry of Electronics and India. Dr. Y. Purushottamji is an eminent scientist with a distinguished career in material science and engineering. He earned his PhD in physics from Osmania University, specializing in the influence of monovalent and divalent additions on the properties of hexagonal ferrites. He has so many achievements, such as he developed ultra high purity 7N germanium, successfully supplying 5 kgs of 7N germanium ingots to DRDO. Automated and sale of hafnium metal production, demonstrating Kroll's reduction process and preparing 15 kgs of hafnium metal sponger for aerospace and defense applications. Established an automated sodium reduction system to improve the metal powder, transferring the technology to industry partners. Proceed 35 kgs of structural grade tantalum powder and supplied it to critical organization like DMR at Hyderabad. Designed and implemented micro enabling sintering of refractory metals and ceramic powders. Dr. Purushottamji has over 70 publications, 3,200 scientific titles, and multiple Indian patents, reflecting his profound impact on advanced material science. He has spearheaded 30 major products, including the transfer of cutting edge technology critical for national advancements. His exceptional achievements have been recognized through several prestigious awards, such as Boy Scouts Fellowship in the year 2003, Best Project Execution Award in the year 2023, presented by Honorable Defense Minister Sri Rajnath Singh ji, and international recognitions like the Young Researcher Award for Best Paper at the IUMRS National Conference in Japan in the year 1997. Dr. Purushottam's influence extends beyond research. He has organized and participated in over 60 national and international conferences and workshops, mentoring young scientists and advancing Indians' capabilities in materials technologies. Thank you, sir. With this brief introduction, I would like to hand over to the session to a resource person, sir. Please welcome, sir.
Madam, good morning. Good morning to everyone, all faculty members. My voice is clear, madam?
Yes, sir, it is audible, sir.
Okay, thank you.
Madam.
Sir, you are not audible, sir.
సార్ మళ్ళీ రిజైన్ అవుతారు.
Now I am sharing my screen.
మేడం మళ్ళీ చెప్పండి.
Sir, you are not audible again, sir.
No, I am able to hear your voice, madam. I don't know. Is anyone is controlling my this one?
Excuse me, sir. Sir, you are not audible. Huh?
But my voice is audible. I don't know.
Sir, okay, sir. Okay, sir. Carry on.
Voice is audible, sir.
When screen share, you see there is an error has been occurred. Please try again.
All right.
I'm not able to share my screen.
Yes, sir. Please share, sir.
Okay, just a minute. So I'm getting a screen like that, can't share your screen. I don't know. Again, I will rejoin. Sorry for the late. Is it my slides are visible?
No, sir.
No, na.
No, sir.
So I will again, rejoin. Okay.
Okay, sir.
Okay, sir.
Join अయ్యారా సార్? Okay, sir. సార్ షేర్ చేస్తుండు చూడండి. Yes, sir. The screen is visible now, sir. సార్ వాయిస్ వినిపిస్తలేదు. వాళ్ళకి వినిపిస్తుందా? మన వాళ్ళకి సార్ అడిగితే వాయిస్ ఫుల్ అని పెట్టి PT or not. సార్ వాయిస్ వినిపిస్తలేదు. If it is not moving, yes sir, moving ahead. వినిపిస్తుందా? ఎవరికి వినిపిస్తున్నా? Sir, you are not audible, sir.
Sir, you are not audible.
Now my voice is clear, sir?
Yes, sir. Yes, sir.
Yes, it's coming.
Okay, thank you. So CMET, what I want to tell is that CMET is established in the March 1990, and so from ITI, diploma, BSc, MSc, PhD, BTech, MTech, PhD, like that. So we have opportunities for students. So my advice through you that students has to go through our website time to time, and we have 3 laboratories. One is at Pune. Our headquarters is also at Pune. Another laboratory is in Thrissur, Kerala, and third one is in Hyderabad. So we 3 laboratories are working in 3 different areas. In Pune laboratory, core competencies processing thick film materials and chemicals, electronic packaging materials, sensors, optoelectronic materials, and in Thrissur, it is a high-tech ceramic processing, multi-layer ceramics, micro substrates, multi-layer actuators. In Hyderabad laboratory, our core competency is materials purification, ultra purification. We are developing ultra high pure materials, and refractory metals, alloys and compounds, compound semiconductors, there, RoHS testing and certification, and e-waste management. Another societally important project is e-waste management. So that also we are working. And we are going to tell briefly about this one. And in the month of June 2023, Ministry of Mines, they identified 30 critical minerals for India's, growth, development, and out of 30, I mentioned in these tables. So there are like many metals are there, and in the red color, whatever is there, cadmium, cobalt, germanium, hafnium, and these are all where our contribution is there. Indium, lithium, niobium, nickel, rare earth elements, then silicon, tantalum, and tellurium. So out of 30, around 12, we have a technology with us. And some of the materials we are going to discuss in today's lecture. And these are the R&D activities. Whatever the technology we developed is ultra high pure metals, tellurium, cadmium, gallium, and now zinc and germanium also we now developed the technology. In the category of refractory metals, it is a tantalum, niobium, and hafnium. So these are all the their melting point, boiling point I collected from the textbook. Coming to ultra high pure metals, as we know, this 99.9% is a high pure material. It means the 0.1% is having an impurity. In terms of ppm, that is parts per million, it is 1000 ppm. So a metal which is having 99.9%, that itself is a high purity and which can take care of many domestic applications. But certain high tech applications, ultra high pure is required. It means that the impurities has to be reduced. So from 0.1 percentage of impurity, we developed the process technology and we are able to successfully reducing the impurities from 1000 ppm to 0.1 ppm. For a period of time, we developed this technology and we are producing different materials and we are supplying to strategic sectors. And another area of activity is the ultra high quality silicon carbide single crystals for advanced electronic devices. We are making this crystals, silicon carbide crystals, by PVT technique, that is called physical vapor transport technique, and 2-inch diameter this crystal bowls we supply to DRDO, and they are making silicon carbide wafers, substrates and then wafers. So now work is going on for 4-inch and 6-inch SiC bowls. And another important activity is that is called RoHS compliance. So this is for industry. If anyone industry established if they are an exporter or part of the electrical and electronic supply chain, and that products has to comply with RoHS regulations. Otherwise, as per rule e-waste rule 2016, so that the firm will be eligible for penalty. And there are certain elements are there like cadmium, lead, hexavalent chromium, mercury, polybrominated biphenyls, polybrominated diphenyl ethers. In a particular electronic component, these are the limitations. For example, in lead 1000 milligram in kg, cadmium 100 milligrams, hexavalent chromium 1000 milligram, mercury 1000 milligram, and PBB 1000 and PBDE 1000 milligram per kg. Like this, there is a restriction of hazardous substances. Limit is there, and that we have a facility in here in CIMET Hyderabad. We developed the testing methods and certification. Our laboratory is a NABL accredited laboratory as per ISO 17025/2005. And this is the first government laboratory in the country. So more than 200 industries, they are utilizing our testing and certification facilities. We are giving RoHS certification. Coming to refractory metals, so these are all the refractory metals, and normally widely accepted definition is that the refractory metals is having a melting temperature above 2000 degrees centigrade. And tungsten, molybdenum, rhenium, niobium, tantalum, hafnium, osmium, and ruthenium. These are all comes under refractory metals groups, 4th and 5th group metals. And this first 6 are having major industrial relevance. And osmium, ruthenium is it is mostly for R&D purpose. And this is another as a function of melting point. So these are all the more than 2000 category comes under this refractory metals, and because of its intrinsic properties, it's these materials are having applications like as these are all high melting point materials, so they can excellent applications of high temperature applications, and they are very good corrosive resistance, so that they can use in chemical engineering. And because of low electrical resistance, they are very good for wiring in a furnace high temperature applications. And because of low vapor pressure and evaporation rate, they are having vacuum and furnaces applications like that. Now this tantalum, we are discussing about the processing of tantalum metal powder. This comes under these are the 3 minerals: columbite, tantalite, microlite, woodgenite. These are the chemical formula, where in this mineral, this tantalum and niobium are available together in the form of oxide, and these are the major sources. And in India, we have a mica mines, and these 4 states, Bihar, Madhya Pradesh, Rajasthan, Karnataka, these are the mica mines are there. And this columbite tantalite is coming as a byproduct. So this is under the custody of our atomic energy, AMD, and we are purchasing ore from them. And this importance of tantalum is the capacitor applications. It is a very good, immune to our human body. This one, so it is having a lot of medical applications, alloys, carbides as cutting tool applications, and chemical industry. So as an alloy, these are all useful for jet engines, high temperature, high efficiency, low emissions, and carbides as a cutting tools. And in chemical industries, this tanks, pipes, linings, like that, there are number of applications are there for this metal. So these are some of the examples: autoclaves with a tantalum liner. These are the structural product, and high temperature. This is thermowell, and this is a construction of heat exchanges for heating, cooling, and recovering of hard sulfuric acid. So sulfuric acid manufacturers, because it is a tantalum is immune only to this HF, that is called hydrofluoric acid. So remaining as acids like nitric acid, sulfuric acid, hydrochloric acid, it doesn't have much effect. So this fabricators are good. They are all using as a heat exchangers using this tantalum. And these are the various types of cutting tools, tantalum carbide. So as I told you, this major application is in electronics only as a capacitors. So all mobile phones is having a tantalum chip capacitors. So because of it is a highly reliable and a long life, and volumetric efficiency is much more, and they are resistant to temperature changes up to 200 degrees centigrade. It doesn't have any effect of these tantalum capacitors, and it works at low voltage, so that it will saves battery life. And so these are the normal capacitors. And this in this tantalum capacitors are, tantalum acts as an anode, and MnO2, manganese dioxide, as a cathode, and in between the dielectric layer is a tantalum pentoxide. So these tantalum capacitors are, various types are there. And in our ECIL Hyderabad, they are making hermetically sealed capacitors, and they are using in electronic voting machines. These tantalum capacitors are having a lot of applications in audio, video, and mobile, and our laptops, because of high volumetric efficiency. So this is the process what we developed is complete up to from ore to anodes. Then we sintering furnace, and then capacitors we prepared and we tested. For capacitor grade tantalum powder has been produced, and so this technology we transferred. And in this process, as I told, in the columbite tantalite, the tantalum, during the extraction of tantalum, the left out material is contains niobium, that is called to tantalum feed raffinate. And then that also we extracted niobium from tantalum feed raffinate, and there this intermediate product is niobium hydroxide, that has been converted into niobium pentoxide. And then aluminothermic reduction here, for if you want to make any metallothermic reduction is required. In the case of tantalum, we used sodium as a reductant. In the case of niobium, it is aluminum. So Nb2O5 plus Al, that is giving Nb and Al2O5. And that niobium thermate has to be purified further by electron beam melting, which is having facility at NFC. So we prepared high purity niobium, and this is a 10 kg batch size. So when we give a 10 kg of niobium reduced thermate, so we got 6.5 kg qualified niobium for after EB melting. This is for VSSC, Vikram Sarabhai Space Center. So this technology we demonstrated to the QC team of VSSC successfully. Entire process demonstration has been taken place. And after developing niobium and tantalum and niobium, then we are now discussing with the third metal, that is called hafnium. So here, this hafnium belongs to the refractive metal group 4th B, and hafnium is used as an alloying element for making refractory alloys, which are used in aerospace applications. So these rocket thrusters and nozzles, which now, if you know, if whenever we are say watching the any satellite launching, ISRO is now launching number of satellites from Sriharikota. So we used to see the the fumes are coming out. These are the five these are the rocket nozzles and thrusters. So these are all the rocket nozzle thrusters are making of this alloy, because it will withstand high temperature and high stresses. So here this C103 alloy, that is called international name, and that is a silicide coated niobium and C103 alloy are well proven materials for thrusters and nozzles. Requirement of hafnium for space applications in our country is substantial, as India is having a very ambitious space program. And in this C103, and our ISRO named it as a NeoBot 103 alloy. This hafnium is an important constant because it is a combination of three metals. NeoBot means niobium, hafnium, and titanium. So this is the refractory alloy of choice for rocket applications. And hafnium forms alloys with iron, niobium, tantalum, titanium, and other transition metals. And the alloy of this tantalum hafnium carbide, Ta4HFCy, is a melting point of 4215 degrees centigrade. So this is one of the most refractory substances known till now. Such a very high temperature applications are there, and this is the where is the availability of this hafnium? It is available in the ore that is called zircon. So hafnium is available with zirconium. When in the previous discussion, what I told, columbite niobium, it is a tantalum and niobium. Columbium is another name of niobium. So tantalite, columbite, it is a combination of tantalum and niobium. Whereas in this zircon, it is a hafnium and zirconium. But hafnium is with less quantity. It is between 1 to 2%. So this ore is available at Kerala because of sand coastal area is there, and that is being processed by KMML, Kerala Minerals and Materials Limited. From there, that processed ore will come to in a nuclear fuel complex Hyderabad for they are recovering zirconium. So this zirconium and hafnium are available together, are the most difficult elements to separate from each other. And after extraction of zirconium, the effluent raffinate is having a hafnium, as I told, in the small quantities. So that is our input material. So in addition to some percentage of zirconium, hafnium is also there. 2 to 4 GPL is a concentration of hafnium. So that we developed, and we are supplying regularly to the VSSC. Now, next societal important activity what we are doing is the e-waste management. So as we know, e-waste is a waste electrical electronic equipment that is known as e-waste, and we know every day we are facing this e-waste is generating tons of e-waste is generating in the country every day, and now this e-waste is not a waste, actually it is a wealth, because metals and non-metals can be recovered from this e-waste. This e-waste has a lot of valuable metals such as gold, silver, copper, which is available in PCBs, that is called printed circuit boards or motherboard. Without motherboard there is no electronic circuit. So this PPT shows electronic waste and electric waste. Electric waste is refrigerators and washing machines, air conditioners, like that. But whereas electronic waste is this players, computers, laptop, mobile phones, TVs, monitors. So these are all the different types of percentage. And this e-waste can be classified into 6 categories. That is temperature exchange equipment, screens and monitors, TV, monitors, laptops, notebooks, tablets, and lamps, large equipments, small equipment, and IT and telecommunication equipment like mobile phones, GPS routers, PCs, printers, telephone, like that. So till now, actually, in the case of e-waste, we used to follow linear economic system. It means make, after we used to purchase, and that has to be used, and after that one it has to be disposed. But since our natural resources are depleting, now this is the new business mantra is the circular economy, so that we can recover the resource and we can send it back to the manufacturing loop. So this is a circular economy. Sustainability and circular economy is the now business mantra for the current period. And this is the discard rate of electronic items. See, mobile phones discarded is 1 to 3 years, PCs every 2 years, camera 3 to 5 years, television 10 to 15 years, refrigerator 10 to 15 years, washing machine 10 to 15 years. IT accessories are very fast. So you see, you can you may be aware that this many metals can be recovered from a mobile phone. There are so many metals are there. And this is a weight versus value distribution. If you can see in the TV board PCBs, this is a precious metals like gold, silver, palladium. It is a PCBs 85%, mobile phone 93%, like that. So these PCBs are very good resource for the extraction of precious metals. And if you process 1 ton of PCBs, this is the material recovery. Gold, you can recovery 0.279 kg, it means 279 grams, and platinum, palladium, and indium 0.093, 93 grams, silver 450 grams, copper 190 kg, aluminum 145, lead and tin 30.8%, 8 kg. And in one PCB, these are the value distribution of metals. Gold is 65%, aluminum 4%, copper 14%, silver 5%, and palladium and PG, platinum group metals, is 12%. And these are the what metals are what for they are using in PCB manufacturing. So platinum they are using for contacts, switches, lead-free solders, multi-layer ceramics. MLCs, gold is ICs, bonding wires, silver is contact switches, and copper conductive paths, connections, ruthenium resistors, hard disk, palladium, like this. So different metals are there for the PCB manufacturing. There are varieties of PCBs that now they are available in the market. And in our country, 90% of this e-waste is going towards unorganized sector only. And the major share goes to a city called Moradabad in Uttar Pradesh. So where they are making extracting some of the items, not fully, but their unscientific method they are doing. And with the hazardous practices in unorganized sectors, you can see the picture how they are they are polluting the environment. At the same time, they are themselves exposing to this hazardous environment. If unscientific method they are handling, there is no proper safety is not taking care. So if you can organize the same activity in the organized sector, then you can minimize this hazards. Environment pollution can be and people can their safety and health issues also can be minimized. So for this purpose, actually, this impact of environmental impact of recycling in unorganized sector is that process used in recycling or recovery of valuable substances involving emissions of hazardous chemicals in air, water, and soil, which causes harm to environment and to the society. Whereas in the organized sector is recycling plastics, glass, metals, etc. This recycled scrap is now after recycling, this will go to the big smelters located in the abroad. So for the recovery of precious metals causes a revenue and resource loss to the nation. To bridge this gap only, the government of India, they give a project to Cement Hyderabad, and we are now reducing, recycling, refurbish, and reusing. We are working, contributing significantly in this area. And advantages of recycling of e-waste is the asset recovery, reduction of need for landfills, reduction of junks and clutters, release and reuse, resell and reuse, and we can create a number of jobs. These are the opportunities are there. Raw materials for manufacturing is available by recycling. Valuable metals can be recovered in the e-waste in pure form. That is advantage. And reduce energy consumption, reduce carbon footprint, good sources of engineering plastics. Like this, there are many, you can develop the, new technology, employment generation will be there. But there are some challenges are there where, poor collection of mechanism, because that has to be established. Otherwise, if you establish a e-waste facility, but if you are not getting the input material, then there is no use. So that has to be full flow mechanism has to be established. And as we know every day, this e-waste is mixing with municipal waste. So this awareness is very much required. And we are bringing informal sector also to our center for the training. We are giving training, and we are inculcating the what type of this has to be done. Otherwise, they will be exposed to themselves for this hazardous environment. So in a PCB, as we discussed, these are the metals: gold, palladium, silver, nickel, iron, ferrite, copper, and polymer is there. And this extraction is involves a lot of engineering, like hydrometallurgical, electro refining, smelting, calcination, and depopulation. These are the activities. So this is a process flow chart: collection of PCBs, depopulation, segregation of components, characterization study of depopulated component groups, pyrolysis of different component groups, and recovery like gold, silver, platinum, palladium, tantalum, and niobium. So this process flowchart has been established in our center, and we transferred also this technology to industry. And after phase 1 and phase 2, in the phase 3, actually this is not a phase 3, but government is by PPP model, our Ministry of Electronics and Information Technology, Government of Telangana, and then one industry called Greenco has established one center of excellence on e-waste management. We are giving now complete recycling solutions for end of life printed circuit boards, lithium-ion batteries, phosphors, permanent magnets, and this photovoltaic modules, solar panels. So we are giving a training and skill development to MSMEs, startups. Then we have a MTech and PhD program. We have a tie-up with IIT Hyderabad, and we are giving time to time, e-waste dismantling and segregation, the 3 days skill development training program to formal and informal recyclers. And from academic year 2020 onwards, we are running one MTech course on e-waste resource engineering and management in association with IIT Hyderabad, and we have a signed MOU with different universities for a joint PhD program. Then in this skill development training program, so this is we have a dismantling facilities there, and we are inaugurated this, and we are rolling advertisement is there. So 3 days training course, it is a 3,000 plus GST, which is 3,540, and number of batches are coming from all over India, and Monday onwards is another next batch is also there. So we have minimum 8 people we are able to provide training, and number of these training programs are going on. So where we are giving the e-waste management rules, theory, morning, half day theory, and second half is practicals. So, and like this, we are scientifically, how can you dismantle electronic items like keyboard, printer, computers, laptop, mobile phone, all types of e-waste we are, giving hands-on experience. So first our people, our project staff is demonstrating, and then they are themselves are, handling how to dismantle it and segregate, because this itself is a big business. So if you are sourcing e-waste and if you are able to dismantle and segregate the components, there are hundreds of components will be there in one electronic item. So if you are able to send it back to the refurbishers, because now in the market refurbished products also is available. So if that is also, if you are able to establish, and this is very good business. So this is a CPU, laptop, like this training is going on continuously, and we are giving a certificate for the participants. Coming to ultra high pure materials, again I am bringing back to this this slide. So as I told, this 99.9% purity, and bringing, we are developing up to 99.59, total 7 nines. So a metal which is having a 99.9% purity and 7N, lot of value addition is there because of this, ultra high pure. If a metal, for example, zinc, 99.9% is coming around 300 rupees, whereas 7N it will be 1.5 lakhs, more than 1.5 lakhs. And some of the metals, critical metals, are not available in the market. So we are this kind of development is there. And why this ultra high pure is very much required? Because these are all having, strategic applications like IR sensors for missiles, night vision binoculars, and solar cells for space applications, and detector applications, where these ultra high pure materials are required. This is a normal ultra purification methods. There are various methods are there. Impurity elements are removed from the base metal by eventually transforming them from one phase to the other, like liquid to gas, gas to solid, or solid to liquid. So here, there are many techniques are there, like distillation, sublimation, zone sublimation, chemical vapor deposition, zone refining, crystallization, and electrolysis. So whatever we developed the technologies, we are following the distillation followed by zone refining, because you can handle these materials in kg level. So distillation followed by zone refining, because in the distillation we are converting from, we are taking the metal, solid metal, converting into liquid, from liquid to gaseous. So that is the way this purification is taking place. And in the case of zone refining, we are taking the solid material, then converting into liquid, then there also zone refining is taking place. Now that we are going to discuss. And this is the process flow chart, and our input material, what we are taking is a 3N purity, which is available in the market, and that is the we are loading for the distillation, that is called vacuum distillation. So there, different types of experiments we have to do. We have to analyze time to time, and after that one, purity, output of this vacuum distilled material, if you analyze, it will be 5N or more than 5N. And again, as I told you, this 3N is itself is a pure. So 5N also is having a lot of applications. If you want to further reduction in impurities, then only you have to go for zone refining. So there, this distilled material, first we have to do uniform melting. We have to make an ingot, and that will be loaded for zone refining. And after completion of zone refining, there is a technique is there. So that output material, what I want to tell is this, that is the more than 7N or more than 7N. And since it is a ultra high pure materials, and very high pure, so this entire process, either vacuum distillation or zone refining, this has to be done under clean room. That is a very, very important. Otherwise, the impurities which are flowing in the atmosphere can, interact with this purified materials, and we cannot claim that as a ultra high pure material. So in this, for any metal, there are two intrinsic properties are there. That is vapor pressure and distribution coefficient. So this graph shows the vapor pressures and distribution coefficient of impurities. Almost all periodic table, all elements are there in this one. And whatever the metal you are purifying, that high vapor pressure of that metal, first it will be removed. And after that one, the surroundings is whatever the metals vapor pressures are there, that elements will be again, you have to purify, you have to convert that solid into liquid. Then in the second time distillation, the target metal only will be purified, and in the third one, only target material only will be obtained. And in the distilled material, if any impurities are there, that that has to be removed by zone refining, where impurities distribution. If you see this right side, this distribution coefficient of various, so less than 1 will be segregated towards the left, and more than 1 will be segregated towards the right hand side. That we are going to see now. And this clean room, we have a class 10,000. It is nothing but the number of 2.5 micron and above size particles in 1 cubic feet area will be less than or equal to 10,000. Then only it is called class 10,000. So as told, this clean room environment ensures prevention from settling of impurity particles, such as many are there normally available floating in the atmosphere. These kind of impurities can be restricted in the clean room. So here in the distillation distillation process allows separation of the major matrix from other impurities by vaporizing at its boiling point due to differences in saturated vapor pressures of impurities. Impurities having lower vapor pressures and higher boiling points compared to major metal what we are going to be purified will be discarded as a residue. So this impurity segregation efficiency depends on vapor pressure difference from that of target metal, and soaking temperature, and the initial concentration of the impurity in the starting material, and yield of distillation depends on these parameters as also on soaking time, and these are the process parameters. So, and in the case of zone refining, this is a metal ingot, this is a metal bar. Okay, just you think that this is a metal bar, and this is one heater. You have to heat up to the melting point of that metal. So in this heater, this is having some fixed diameter. For example, if you take a heater diameter is 10 mm. So in this 10 mm heater, this area, this zone is having since you are heating up to the melting point of that metal, it will be in the liquid condition. And in this liquid condition, you see, assume that from this entire metal ingot will be in hot condition only because of conductivity, but only certain area where this zone temperature is up to melting point, this only will be in the liquid state. So what is happening, if you move this heater from one end to the other side, or other side to the left from left to right or right to left, whatever, this is, this segregation, what is happening now, impurities which are there in this liquid zone will be segregated towards the ends. So what is happening, this from one end to the other end, if you pass this, heater from one end to the other end, that is called one pass. Like this, if you are doing several passes, and what is the, output of this one is that the impurities which are distribution coefficient, let's say, or segregation coefficient is which is having less than 1 will be segregated towards the end side, and more than one impurities are segregated towards the right side. And if you analyze, the middle portion is having a pure than both ends. So that is what going to happen. And this is the, instead of one heater, you can put multiple heaters so that that reaction rate will be fast. Instead of one tube, you can put multiple tubes. That is, it is our process, capacity. That is not a problem. And this is a very, actually, this zone refining is a very old technique. So that this is, but with this, it was found that majority of metallic impurities like zinc, copper, lead, bismuth, iron, nickel, chromium, etc., accumulated at the tail end section of the ingot, while in the middle region of the impurity level was much below than the initial concentration. That is what I am telling. So you have to cut it, then middle portion will be of high pure, then both ends again you make a uniform melt, then again you have to do zone refining. So like this, the zone melting has proved extremely powerful and versatile technique for many applications for for preparation of 7N grade material. So in the distillation, what is happening is efficient for lower purity range from 3N to 5N, whereas zone refining is efficient at a higher purity range from 5N to 7N. So one has to do optimization of process parameters for each metal. Like these are the process parameters: vacuum level, vapor pressures of impurities at soaking temperature, and area of evaporating surface play the key roles for efficient distillation. And segregation coefficient of impurities at zoning temperature, zone width, zone travel speed control the zone refining. So these are the parameters one can do if anyone want to do any metal purification, or you want to develop a new technology. These are the experimental parameters. And distillation is a purification process brought about during liquid vapor liquid transformation, whereas zone refining is a liquid to solid and vice versa, solid to liquid at freezing or melting point. And these are our class 10,000 clean room, and we have a dedicated facilities for cadmium, tellurium, and zinc and germanium. And after purification of this is the 7N zone refined tellurium, and this is a cadmium ingot. And we used to send samples to NRC Canada for GDMS analysis. They will analyze for 60 elements, and major matrix will be whatever the metal to be purified, that will be there. And now next activity is the ultra high pure zinc for detector applications. So as this is a textbook information only, as we are aware, zinc is having many applications for the human beings, and its most common use is an anti-corrosion agent by way of galvanization, a process of its coating on iron to protect it against corrosion. So this is a major applications, and paints, in the paints also used as a zinc oxide, and zinc sulfide is using making dials, fluorescent lights, and TV screens. And this for the zinc metal is available in large quantity in the country with the Hindustan Zinc Limited, Udaipur, and Binani Zinc Limited, Binanipuram. So these are the normal zinc, 99% or 99.9%, but high purity zinc is used for making compound semiconductors like cadmium zinc telluride for detector applications, zinc selenide for electro-optic modulators, and for doping of semiconductors to make p-type. So these are some of the applications, high-end applications like cadmium zinc telluride detectors, and this is the zinc selenide focusing lenses. So here, this is again our process flow chart. So we developed this process technology, and that we are going to discuss now. And again, these are the vapor pressure and distribution coefficient of impurities, and these are the technique, vacuum distillation setup. And you can see both what is this carbide graphite crucibles are there. And what we are doing, this is a bottom crucible and this is a top crucible, and we are loading the raw zinc. This is the metal what we purchased from the market that we are loading in this bottom crucible, and this will be kept on the top. And this is a lid. This is a lid, and this is a copper arrangement. Water, cold water circulation will be there, and this will sit on this top crucible only to this, since it is a we want to create a temperature gradient. Both will be in a furnace. Both will be in a furnace, but we want to create a temperature gradient. Then only purification will take place. So how to create a gradient means this empty crucible will be on the top of the empty crucible. This will sit. So this will touch. I will show you. You see like this. Both are in the state, and in the bottom crucible, the metal to be purified will be loaded, and this is a this is another empty crucible that is called collector. So you can see here the schematic diagram of the essential components of vacuum distillation system is that a pit furnace, one furnace is required, retard, flange assembly, evaporator, collector, condenser setup, cold trap, and vacuum system. So here what is happening, the metal, whatever the metal to be purified has to be loaded in the bottom crucible, and we have to heat up to the melting point of that metal. And in that particular batch, for example, if you are taking a 1 kg metal, so in that 1 kg metal, whatever the impurities are there, and when we are bringing up to the melting point of that metal, the low melting materials or impurities, whatever is there, they will simply evaporate. So, and since it is under vacuum, and it will go and go to the top graphite crucible, and this top graphite crucible is attached with a cold water circulation. Copper cold water is sitting on this one. So what is happening? This will be at lower temperature compared to bottom crucible. So all these vapors, whatever is there, it will go and condense. All these vapors will be condensed in the top crucible. That's why we are keeping a empty crucible, and that here we are loading the material. So you can see here, you see this is the raw material we are loading in the bottom crucible, and after distillation you can see this is the empty crucible, whatever was there, all these impurities will go and condense here, and you can see, you can get a like this shape, same shape here. These are the metallic impurities. So whatever the left out material is there, that is that again we are going for the second distillation, and we are heating above the melting point. So first distillation up to the melting point, and above the melting point, then the target metal only will come out, and that again it will be deposited on the top crucible, and this is what purified metal you can see. And since it is under vacuum, after becoming coming to the room temperature, we can easily take it out, and in the clean environment. This is the distilled zinc. In the case of zinc, I am telling one example. So this is around 2 kg batch size. You can see here purification of zinc by vacuum distillation is a raw material, and first we are removing the high vapor pressure of this zinc, whatever is there as a first fraction, and the residue, whatever is left out, that we are loading for the first distillation. So what is happening? Only zinc only will come out, and from that one we are further distillation. So where you can get only zinc plus surroundings high vapor pressure impurities, that will be removed, and only zinc, that is called of 5N purity, 99.39. And here you can see input material is 98.5% whatever we purchased from the market, and you see, this is the analysis report where other impurities are okay in ppm, but lead is in percentage, 1.5 percentage. So after vacuum distillation, when we analyzed by using ICP-OES equipment, you can see there 1.5% of lead has been reduced to 0.45 ppm. So such a effective technique, this vacuum distillation, and other impurities are went up to non-detective range. And you see, you can finally you are getting 99.999 percentage purity. So here in this is the advantage of this vacuum distillation is that in this crucible you can load up to 5 kg material. So whether 1 kg or 5 kg, so process time is also same. So you can enhance, you can keep up to kg level vacuum distillation. You can get a ultra high pure metals. Then if you want to further purify from 5N, the purified distilled material, we have to cut it into pieces and put it in a boat, quartz boat, and you have to melt it uniformly so that it will become a rod, like this, a rod that will be loaded for the zone refining. So here these are the heaters. Again, here also we have to heat up to the melting point of that metal. As we discussed, the liquid, the zone, whatever is there, in that one, whatever the impurities are available, they will be segregated towards the ends, and middle portion will be the of high pure. And this is the 7N grade zinc ingot. So this is a like this we used to supply tellurium, cadmium, and gallium also we developed up to 7N. And the next element is zinc. What happened during this project? Actually, this was sponsored by BRNS and they IGCAR, Kalpakam, Indira Gandhi Center for Atomic Research, Kalpakam. They asked us to make not only ingot, but that has to be converted into granules. So here, less than 3 mm diameter granules we have to prepare of 7N grade, and that has to be supplied. Then for that purpose, so after zone refining, we have to analyze. And here, this is a HR ICP-MS at NGRI. We analyzed, which is confirming a 7N pure zinc. And this ingots has to be converted into granules. For this, we designed this is a granulation system. So another, advantage of our technology is that whatever the process equipments we used were designed indigenously designed and fabricated. So here, this is a metal granulation system. And again, in this one also, this is a, furnace come retort. Inside, there is a graphite crucible is there, an orifice is there, and this zone refined ingot has been loaded in this graphite crucible. And after reaching the melting point of that one, manually we used to open the orifice, and it used to come down. We did number of experiments. Initial experiments were failed because they are not uniform. Different sizes are there and not uniform, and sometimes it is a lot of agglomerates used to come out. And we again, this process parameters has to be optimized, and we optimized, and finally we got a less than 3 mm diameter high pure zinc shards. So with this, we around 2 kg shards we prepared of less than 3 mm diameter. This is the target our has been given by our funding agency, and this we supplied to the IGCAR for their this CZT alloy preparation for detector applications. So like this, we successfully prepared the 7N grade high pure zinc for detector applications. So I hope my slides are visible and voice is clear.
Yes, sir. Voice is clear, sir.
Thank you. So next is that we are going to discuss about the recycling of scrap germanium to ultra high pure germanium. This is another interesting, very interesting metal. So these are all having applications. Germanium, it is atomic number is 32, mass is 72.64, and density is 5.323, and they have a infrared optics, fiber optic systems, electronics and solar, polymerization, catalysis, phosphorus, metallurgy, and chemotherapy. These are all having ultra high pure germanium applications. And this is the process flow chart what we followed. So actually, since our laboratory is a high pure metals laboratory, so our DRDO, solid state physics laboratory, Delhi, the management contacted our management, and they informed that they have a contaminated germanium, because they are having a very big program at single crystals by Jagralski technique. So during the process, some amount of germanium will be contaminated. That is a process. So we cannot avoid. And that contaminated germanium has been stored, and they told us to purify, bringing back to again whatever they are purchasing from the market. So we have to bring back to the 7N germanium. They are purchased from the 7N, and this contaminated germanium has to be bringing back to the for their input material for crystal growth experiments using Jagralski technique. And so then they told us to submit so I submitted a project. This is the process flow chart, that we are taking contaminated germanium, whatever is available at their laboratory, that has been analyzed. Then, and germanium melting point is 950 degrees centigrade. So this cannot be done by resistive heating. Resistive heating, whatever the conventional resistive heating, whatever I shown till now, is this whether it is a tellurium, cadmium, zinc, their all melting points are below 500 degrees centigrade. But this germanium is 950 degrees centigrade, and this resistive heating may not be effective. So we proposed induction zone refining, because induction heating is a very well-known technique for the industry is using tons of kgs of tons of metals. If you want to melt, it is an induction melting. But that induction melting technique has to be bringing back to the zone refining. That is the only novelty in our project. So after induction zone refining, we have to analyze, then we are melting and casting, then packaging and supplying the material. With this process flow chart, we submitted a proposal. And here, this, as we know, this induction heating is the process of heating an electrically conducting object, usually a metal, by electromagnetic inductions through heat generated in the object by eddy currents, that we know. And this electromagnetic induction or induction is a method of heating electrically conductive materials, and this is a this induction heating process, and these are all known information only. And these advantages of induction heating is it is a quick heating. It is like almost similar to microwave heating. Microwave heating is a you cannot heat this metals, because metals get reflected from the microwaves. Metals will not penetrate through the metals, whereas induction, that this problem is not there for the metals. Induction is the very much preferable for this metal, because of it will be quick heating, and fast to startup, high production rate, and ease of automation and control, reduced floor space, and it is quite safe and clean, and maintenance also is less only. And here, this germanium is used as a semiconductor in transistors and various other electronic devices. This historically, the first decade of semiconductor electronics was based entirely on germanium. Presently, germanium's major end users are infrared optics and in solar cell applications. Germanium compounds are also used for polymerization catalyst and have most recently found use in the production of nanowires. Zone refining techniques have led to the production of crystalline germanium for semiconductor applications. So in this project, we designed and fabricated indigenously induction zone refining equipment, and this process parameters we optimized for 1 kg batch size. And in this project, these are the 2 patents we submitted. Actually, now we got application that is now in the public domain. So one is the methods and systems for purifying germanium. Then design and fabrication of induction zone refining system. These are the 2 techniques, 2 patents we filed. And this is the germanium melting by induction. We can made a ingot, and this is a ultra high pure germanium. I'm not giving the details about our induction zone refining system, because since our patent is under public domain, after awarding only I have to inform, otherwise there is a problem. So this has been analyzed after induction zone refining. We sent the samples to Canada, NRC, National Research Center, for GDMS analysis, so that confirms 7N pure germanium with respect to metallic impurities. And these are the ultra high pure germanium ingots. As per the project deliverables, we have to deliver 5 kg of 7N germanium ingots, and we during the process we made 1 meter length ingot. So as per the requirement of the users, that has been made into 300 mm by maintaining the same purity. Then this has been supplied, these 300 mm ingots supplied to SSPL, Solid State Physics Laboratory, and 5 kg of material because of the project deliverables with analysis reports. And so in the 2020, March 2020, our annual foundation day, during that time, we handed over this 7N germanium to ultra high pure. That time, our Dr. Satish Reddy was the chief guest, and Professor Murthy was the IIT director. IIT Hyderabad was the guest of honor. So during that time, we handed over this. And after that one, in 2023, this project was got a Best Project Execution Award, and I received from the Honorable Raksha Mantri, Sri Rajnath Singh Ji, during DRDO Academic Conclave in DRDO Bhavan, New Delhi. So this is the Project Execution Award. So like this, we successfully developed and executed material, and these are the process. So any questions, please?
Dear participants, if you have any queries, you are welcome.
Good afternoon, sir.
Yeah.
I have a small question, sir. Even though we do it in a clean environment, that impurity process, do we face any problem during the removal of impurities, sir?
No. See, madam, this is under vacuum, na? Treatment is under vacuum.
Okay.
So there is no question of exposing it to our atmosphere.
Okay.
There is absolutely no problem, because whatever is there, as I shown, otherwise I will show you, I will clear the doubt to you, is that, this, 1 minute, madam. You see, this is the,
yes, sir.
This is the furnace. Okay.
Okay.
So this is the retard. In this retard only, that both the 2 graphite crucibles will be there.
Okay.
And this entire retard is connected to the vacuum system. This is a vacuum unit.
Okay.
And this is a control panel for this furnace. And this is a chiller. And cold water circulation is going on in and out.
Okay.
So this is the vacuum distillation setup, and we are here only. So absolutely no problem, because whatever the impurities are there, that will, after reaching molten state, the low melting will be vaporized, and it will go towards this empty crucible.
Okay.
You are getting, because
Yes, sir.
this we are keeping on the top of this one, na?
Yes, yes.
So like this, it will be like this only.
Okay.
So entire crucible, whatever is there in the retort is totally sealed, and this is connected to the vacuum. So there is no exposure for the human being.
Okay, sir. Thank you, sir.
Thank you.
Hello, sir. Good afternoon, sir.
Ah.
Sir, you told us about the e-waste management, and you'll have a training program. So,
Yes, yes.
are faculty members allowed to have training programs, sir?
Anybody, madam, anybody. Because that is a open, you can just see our website, COE on e-waste management, or cmet.gov.in. There is there, and you can, you can contact through email. Anyone can attend, madam. It is not a, restricted.
Okay, sir. Thank you, sir.
Any questions, please? Because otherwise we will go to next, because that is again, it is a different topic.
Please carry on, sir.
Okay, thank you. So next, what I want to discuss with you is that microwave sintering and its advantages. Because in induction heating, I just briefly mentioned about the microwave sintering. So that it is actually we know all these things. Sintering is a complex high temperature process that consolidates and strengthens the loose or compacted particles into a more dense coherent body. So what is happening during sintering? Powder particles from coherent bonds and densify by pore shrinkage. It will, if you want to make a dense material, you have to sinter, whether it is a resistive heating or induction heating or microwave sintering, but the sintering is only to densify. So how it will be densified? The pores, whatever is there, it will shrinkage. Shrinkage will taking place during the sintering process. So there are different stages are there during sintering. Initial particle bonding, neck growth, pore channel closure, densification or pore shrinkage, and pore coarsening. So how pore coarsening will take place? If you want to expose, if you want to do more time, if you are giving more time for the sintering, then first it will densification, shrinkage will take place, or after that one, pores will be coarsened. So that is these are the different stages, and different conditions also there: rate of heating and cooling, sintering time, sintering temperature, sintering atmosphere. So these are all the research topics. We are all very well aware about this sintering conditions, and there are types of sintering is there: activated and liquid phase sintering, activated sintering, solid state sintering. Like this, different types of sintering is there, and in the solid state sintering, the growth of the sinter bond from an initial loose powder contact is characterized as the initial stage of sintering, and in this stage, the neck size is sufficiently small that neighboring necks grow independently of one another. And in this solid state sintering is a microwave sintering and laser sintering. These are all the different types. And microwave sintering is a process for heating powder materials by microwave radiation, so that heating and sintering or melting progressively and directionally occurs within the powder material. So the why microwave sintering is very efficient than resistive heating or conventional heating is that the pore molecules are free ions which are available in that material will respond to this microwave field. And why it is so fast, because every day we are seeing. So why it is? Because of this, what is happening inside the powder material is that molecular friction is taking place, that which result into, convert into a heat within the material. And they are all having various applications are there. And microwaves are electromagnetic radiation with wavelengths ranging from 1 mm to 1 meter in free space with the frequencies. These are the 300 gigahertz to 300 megahertz. And the available allowed bands are 915 megahertz and 2.45 gigahertz is the microwave region now. So this is the electromagnetic spectrum. And why this is a different, fundamentally it is a different from conventional radiation, because in the conduction, in the convention heating, so the heat is generated in the micro in the what is that conventional heating. For example, in the resistive heating, you have to heat up to the whatever the target temperature. That target temperature will take time to reach. Then till that time, our material, whatever the material you are placed in the furnace for sintering, that will be exposed. And after that one, after reaching the set value, you have to maintain certain period, certain hours. Then you have to reduce, and it will take time to come to room temperature. So from loading to unloading, you are exposing your material through the conventional resistive heating. Whereas in microwave, it will be immediately it will reach your set value, and once you switch off the microwave source, then automatically it will come down to room temperature within very short time. So the exposure time we are reducing like anything. And these microwaves can be transmitted, absorbed or reflected depending upon the material type with which they interact. So this is 100% material dependent, this process. And energy penetration is taking place, and absorption is taking place. And you see, this is the one. So this is a conventional and microwave heating. In the conventional, we are loading the material, and through conduction, convection, this heat will be transferred to the sample. And here in conventional heating, the energy is transferred. This is external heating, and it is purely, whatever the material you are keeping, this will become it will become a hot. You can do any material in conventional, and there are energy losses are there in conventional heating. But whereas in microwave, it is a energy conversion, because you are converting electromagnetic energy into thermal energy. Electromagnetic energy into thermal energy, and internal heating is taking place, and it is completely material dependent, and it is a highly efficient. So you can see here, this graph shows the conventional heating, and microwave heating. The set value, for example, if you take 1200 degrees centigrade set value, and it will in conventional to reach that 1200 it will take minimum 2 to 3 hours, depending upon the rate of your ramp rate, whatever we are giving. Even if you give 100 degrees per minute also, it will take time to reach 1200, but it is difficult. So whereas in microwave, since it is a material dependent, the moment if you switch on the magnetron, what is the microwave source, it will release the microwaves, and that microwaves will penetrate and through the material, and that electromagnetic energy will convert into thermal energy, and set value will be reached within no time. And you can, after compared to conventional heating, we have to, in conventional heating, we have to keep the material some hours, maybe 3 to 4 hours, 5 hours, depending upon our application. Whereas in micro heating, it will be in minutes only. From 1 minute to 10 minutes, like that only. You can make a comparative study from conventional heating and micro heating. So like that, this is a lot of advantages is there. And as we discussed, volumetric heating taking place, energy is transferred, and to thermal, and it is a this how why this is possible, because the molecules and ions which are there in the material, they are response, and molecular friction is taking place, and that friction is converting into thermal energy. So these are all the advantages. Many advantages are there. I know high speed, which saves space, reduces scrap, and labor saves is there. And there are many advantages are there. That's why this here you can see how microwave interacting with the material. If it is a low loss insulator, total transparent is there. If it is a conductor, so metals, that's why metals doesn't penetrate. What is happening? Whatever from the generator that is called magnetron, if you keep any metal, it will reflect back and it may damage the magnetron, microwave source itself, because metal is not at all possible. If you want to melt, then you have to go either resistive heating or induction heating for any metal, but microwave is difficult. And so these are all the material dependent procedure, microwave. So these are all there are many advantages are there. And what is happening here, polarizability, space charge polarization, dipolar orientation polarizability, atomic ion polarizability, electromagnetic polarizability, and these are the different types of polarization is taking place in the material. And these are the, and it is a lot of commercial and industrial applications are also there using microwaves. Eating food, microwave oven, we are all observing, now